Hello Year 11 and welcome to our fifth video here for polynomials. We looked at the factor and remainder theorems in the last exercise and we're going to look at a few more ideas around the factor theorem today. And what I'm going to sum this up as to begin with anyway is that if I have some polynomial like we have in this example here, then all of the roots of that polynomial, all of the zeros, will divide the constant term. Okay, so in this example here I've got a constant of 6. Any zeros of that polynomial will go into 6. Okay, so that could be -6 and 6, -3 and 3, -2 and 2, -1 and 1 would have to be the roots. Some of those. Now there's 8 options there. Third order or third degree has got a maximum of 3 roots, but nonetheless it sort of allows us to make a bit of an informed guess rather than just chasing any sort of factors. I'm looking for numbers that go into 6. So let's have a look here and say, maybe we're going to guess, what about 1? Because, you know, 1's always easy to substitute in. And 1 cubed minus 4 times 1 squared plus 1 plus 6 equals, I think it equals 4. So x minus 1 is not a factor. We'll try -1. Still relatively easy, and when I do that, -1 cubed minus 4, lots of -1 squared, minus 1 plus 6 equals 0. That means that x plus 1 is a factor. What are we going to try next? Well, it can't be 6 or -6 because I've already tried 1 and -1, only one of those things left. I've still got to find potentially 2 more roots, and they've got to have a product of 6, but I can't use any more 1s because we've already checked those. So we're going to go with, I'm going to have a look for, I think I'm going to have a look for 2. And what do I get there? 2 cubed minus 4 lots of 2 squared plus 2 plus 6. Pretty sure that equals 0. Okay, pretty good. That means that x minus 2 is a factor. So 1 by -2 times what equals 6? -3, I reckon. So let's try a polynomial of 3. We'll just see if there's any remainder here. And 3 cubed minus 4 lots of 3 squared plus 3 plus 6 equals 0. X minus 3 is a factor. Means that x cubed minus 4x squared plus x plus 6 is equal to x plus 1, x minus 2, x minus 3. Okay, so we could have used some polynomial long division there, but that's generally slower and takes up more space. And just testing to see if we've got a remainder and testing numbers that we we've narrowed down how many we need. That's relatively fast, and we have managed to factorize a cubic equation there. Okay. We have spoken about identically equal polynomials before, telling us that if I have 2 polynomials that are identically equal, then the coefficients of the corresponding terms are equal. Okay, so here's a question that asks us to find the values of a, b, c, and d if these 2 polynomials are identically equal. Now, that polynomial on the left is easy enough to work with. The one on the right has all sorts of things going on. Now, sometimes we have an unknown in the coefficient. That's really easy to work with. But when I have, say, b outside of x plus 4 squared, I think we're going to want to expand these out. So I'm going to say 2x, we're just going to expand this now. Okay, and I've expanded that x plus 4 squared out mostly and distributed c over the x plus 4. So straight up I can see that a plus 1 has to equal 2, okay, because the coefficient of the x cubed here has to equal that there. So a plus 1 equals 2, therefore a equals 1. That's nice and easy. 1 of the 4 done. Also, d minus 1 has to equal 1. Right, we'll just put a box around this so we don't lose it, because we've got to find a few things. D minus 1 equals 1. Right, they're my constants. Therefore, D equals 2. 2 down, 2 to go. Now what comes next? Let's look at the x squared term, coefficients. So bx squared, this is my only x squared term. Bx squared, or so also means that b must equal 0 because I've got no x squared term. There's a mistake there, isn't there? That should be minus 3x squared, I think. I'm going to say, hang on, let's tidy this up. I'm just going to change that question because I'm pretty sure there should be a little 2 there. Oh, that's a typo on my notes. I'll have to fix that up. Okay, now if we just look at the x squared coefficient, I've got a bx squared here. Right, that's the only x squared term on the right, and there it is on the left. So I'm going to say that b equals -3. Okay, because I'm going to equate that one with that one there. 3 down. 3 down, 1 to go. Now, C is... Oh, I made a mistake with the D. That's constant there too, isn't it? Whoops. Forget this one. D, that's a mistake. Scratch that for the time being. Probably should have worked through these in order. Now, my x, if I look at the x squareds, there's -3 here, there's b of them here, so b is -3. Now let's look at the x terms. So I've got 1x here, and over here I've got 8b x's plus c, right, equals 8b plus c. There's all my x terms, equals 1. Now, 8b is 8 times -3 is -24. So c equals 25. That's 3 down, 1 to go. Now we're going to look at the constants. So now the constants I have cubed, squared, unitary, 16b plus 4c plus d minus 1 equals 1. Now 16b is -3 lots of 16 is 48, I reckon. So we've got -48. Now 4c plus 100 plus d minus 1 equals 1. Well, this gives me 52 minus 1 is 51. 51. Subtract 51 from both sides. Take 51 away from this, and I've got d equals -50. And there we go. A, B, C, and D. If that is the case, then they are the values of each of those terms. Who would have thought it? There you go. If you've got any questions, please jot them down, ask me in class, and I'll see you there.